Hello and welcome to Super Duper Uper large numbers. And this is part 1, the largest number and the baby numbers. The baby numbers. Well, so as the title of this series could hint at you, this series is gonna be about super duper uber large numbers. Or just really large numbers in short. And yeah, let's just begin. So, part 1, the largest numbers. I mean, do they even exist? Right? Let's think about that. Right? So does there exist such a thing as the largest number? Yeah. Okay. So I will let you think about that for 5 seconds, and if you want longer time, you can just pause the video. All right. And then time to review the answers. Answer is no. There don't exist such a thing as the largest number. To prove this, we assume such number does exist and call it L. Then that means no number are bigger than L because it's the largest number, right? But let's consider the number L plus 1, and L plus 1 is greater than L, thus forming a contradiction. So we have proven that there exists no largest number. And, well, some of you might say, well, infinity, but I won't touch on the subject of infinity just now, but as the series progresses on, we will indeed learn about infinities and their role in our series. Alright. Alright, so now that we know that there exists no largest number, then here's a little game for you. If we scroll down, what is the largest number you have heard about lately? Leave them in the comment section below, and I won't be revealing the largest number I know that I myself know just now because that will be the real biggest number that I will left in the end of the series. And since I want this series to be bringing progressively more and more large numbers, each larger than the previous episode. So yeah, that's that. But let's focus our gaze on another topic, quite different from this one. What is some small numbers? And by small numbers, I don't mean like infinite has mostly small, like 0.00000, right? And then 1. I don't mean that kind of a small number. I mean something like you can manageably count, like 1. Actually, let's start with 0. 0, 1, 2, 3. Alright, these are what like to call baby numbers. I mean, well, they are natural numbers, but they are quite small and you can really just apply them in real life. You can say there's 1 chicken, 2 apples, 3 houses, 4 rocks, you know, and you can go on, go on, go on. But at what point does these numbers stop being baby numbers? Well, let's say 10, right? Is 10 a baby number? Well, you have 10 fingers, you have 10 toenails, and I mean, you can count 10 numbers easily, right? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's quite easy to count 10. But say if you got 10 bottles of water on you right now, then wouldn't that be a bit ridiculous? Or you might argue that, having more than 2 bottles of water is already quite ridiculous. But say if you carry 10 notebooks to school, then wouldn't that kind of be ridiculous? Right? So, is it a baby number? Maybe it still is because 10, you can really still just count it easily. Hmm. But what if we double that number and then we get 20? Is 20 a baby number? Well, 20, let's think about it. So, if you got 20 apples, wouldn't that be quite a handful of apples? You couldn't hold it by. You couldn't really hold it with one hand. You have to like hug it, you know, and then put it in your chest. So 20, yeah, it might just be out of the baby number reach, but if we use some object that is really small, like droplets of water, then 20 doesn't seem like all that much, right? Because 20 droplet of water is it's pretty much just not even one sip. It's a really small amount of water, right? So, but that wouldn't be fair, right? Because we can get arbitrarily small numbers. No, I mean small objects, and then even big numbers would look like baby numbers when used to describe them, right? So let's use droplets of water as our standard for now. So 20 droplets of water. Well, grammar. All right, standard. All right, 20 droplets of water. That isn't really much, right? But what if we times it by 5? So we get 100, right? 10 droplets of water is not enough to even fill the cap of the water bottle. And 20 is probably enough to fill the cap of the water bottle. Now 100 is gonna be 5 times 20, so it's gonna be 5 caps of water bottles. And since we're going 2 times, that's this from here is 2x, this to here is 5x, then let's go 10x, 1,000. So that will be 50 caps filled with of water bottle filled with water. And I would say that is, around 1/4 of a equivalently 1/4 of a wait. I think I can use special symbols in this app. Wait, let me try that. Yeah, I can. 1/4 bottle of water. Assuming we got a 500 milliliter water bottle. Now we can go 10x again, which is gonna be 100x from 100, and that gives us 10k. 10k, which is gonna be 10 over 4. 10 over 4, and that would be 2.5 bottles of water. Well, I mean, it's starting to get a bit crazy, but not that crazy, right? But if we do the 10, if we times 10 again, so times 10 again, we get, let's use scientific notation. So we got 10 to the 5, or I think that's a million. Yeah, that's a million. So a million droplet of water. So that would be 2.5 times 10, and that would be 25 bottles of water. So that would be like half a box of water, right? So, but we can go even higher, right? We can see a pattern right now. If we just do 10x, then we got a qualitatively larger number. So 10x again, and we get 10 to the 6. So that will be 250 bottles of water, or 5 boxes of water. And I bet you cannot carry that many water, that many boxes of water with you. So now it is 10 to the 6 or 10 million. The large number is everything else baby numbers. Well, we're using droplets of water here, so you know the definition of large number is quite subjective. So it really depends. Maybe you can see two as a large number, if you, but you can also see 10,000, 10 billion as a small number, right? But our large number is gonna be far, far, far more ridiculous than these numbers. And these numbers are what I like to call baby numbers. Yes, they are still baby numbers. Because, well, what I like to define baby number as is things that is still imaginable within the physical realm. So you can imagine 10 to the 6 uh, water droplets, like that's just 5 boxes of water, right? But we can continue with that, so let's just go 10x again, and we get 10 to the 7. And that will be 50 boxes of water. Now now if you live in poverty with a small house, I actually know that that would be a bad example, right? Now if you were trying to drink all that water, assuming you drink like what's the healthy amount? It's 4 bottles of water every day. So each box is like 50 bottles. So that would be 2,000. Wait, 4 bottles, 50 bottles, 50 over 4. That's not a whole number, so that's 12.5. Yeah, that's kind of bad. But that would mean that you need on the average of 12.5 days, or half a month, approximately half a month, to finish one boxes of water, and you multiply that by 50, and that will be something like 600, 600, which is near 2 years. I believe it is around 1 and 3/4 years. Now we can go higher. We can still just go to 10x, or we can go 10 to the 8, and that is really beginning to get crazy, right? You can drink 4 bottles of water every day, and then you will require um, 30 over 4. That's kind of a bad number. So I'll just round it up and use 22. So that will be 20 years. That will be 20 years of drinking 4 bottles of water every day, and then you have to take 20 years to finish all that water. That is quite ridiculous, right? And then we can go smaller and just do four times 4x, right? So we get 4 times 10 to the 8. Wait, actually, we think we have the cool symbol on this one, on this app. It's gonna be 10 to the 8. Wait, I don't think it's working. Wait, it is working. 10 times 10 to the 9, 8, right? Wait, how do I cancel? Okay. All right, now so 10 to the 4 times 10 to the 8, which is 80 years. So that is kind of crazy, you know, because the average lifespan of humans are, well, 80 years. And imagine having to drink 4 bottles of water since you begin living every day, and then you have to drink all the way till you're dead to finish all that water. Now let's sort of it more optimally and 2 times 5x the last number, so we get 10 to the 9, right? And then and let's assume that you drink 10 bottles of water every day, every single day. Actually, let's assume that you drink a whole box of water every single day. Now that is probably a Guinness World Record. I don't think anyone have achieved that, but let's just hypothetically assume that. And that would be actually pretty crazy because based on the calculation here, 10 to the 6 is 5 bottles of water, and this is 3 magnitude higher. So that would be 5,000 boxes of of water. And 5,000 boxes of water, you have to spend 5,000 days. 5,000 days, that would be something like 15 years. 15 years. Yeah, it's around 15 years. So 15 years of drinking a whole box of water every single day, and you need to, and that's what you need to finish that. Isn't that just hard to imagine, right? But you can really see a pattern here. You can just do 10 times the last number, and then you get higher, higher, and higher. Yeah, and each time you do 10 to you do 10 times the last number, this number, for example, sort of just completely obliterate this number, and this number completely obliterate this number, and it goes on. It's like a hierarchy, right? Now, it is pretty hard to comprehend these numbers already, but what if I give you this number? Yeah, that's 10 to the 100. That is called a Google. Actually, let's use the equal sign. And that is really insanely large. And we will just explore how large that number really is when put into the physical realm, and then yeah. But that's for next episode, and hope you enjoyed this one. Have a good day, and please click like and subscribe. Thank you. See you next episode.